All right, let's get right into it. We're going to talk about something that's, at the very heart of how crypto works and sometimes how it breaks apart. We're talking about forks. I mean, how do you even begin to change something that's built to be, well, unchangeable?
Welcome back to CodeAccessHub. So glad to have you here for part 2 of our deep dive on blockchain forks. In the last one, we covered the basics, and today we are getting into the real nitty-gritty, the difference between hard forks and soft forks. This is where all the action happens.
All right, let's set the stage here with the big central puzzle.
The whole selling point of a blockchain is that its history is locked in, right? It's permanent, immutable. But here's the catch. Technology never stands still. It has to evolve. You've got to fix bugs, you want to add cool new features, you need to beef up security. So how in the world do you update a system that's designed from the ground up to never be updated? Well, that's where forks come in. So what is a fork, really? At its core, it's just a change to the blockchain's fundamental rulebook, its protocol. And the fork in the road analogy is honestly perfect. Imagine the blockchain is just chugging along on one single path. A fork introduces a new path. Now, the big question is, does everyone agree to take this new road together? Or does the group split up, with some staying on the old path and others taking the new one? That's the essence of it.
Okay, let's start with the big one, the really dramatic option, the hard fork. Trust me, this is where things get juicy.
So a hard fork isn't just a small tweak. It's a radical change to the rules. And the key thing to remember is that it's not backward compatible. The Windows to Mac analogy is spot on. It's not like a simple software update for an app on your phone. No, this is like throwing out your old computer and getting a brand new one with a totally different operating system. None of your old programs are going to work unless they're updated too. And this is absolutely critical to understand. A hard fork literally splits the blockchain into two. It's a permanent break. Every single person running the software, we call them nodes, has to upgrade to the new rules if they want to be part of the new chain. If you don't upgrade, well, you're left behind on the original chain, which from that moment on becomes its own separate thing. You want a real-world example? Oh, we've got one. Let's talk about one of the most legendary, high-stakes dramas in crypto history, the DAO heist. So picture this. It's 2016. There's this massive project on Ethereum called the DAO. And then disaster strikes. A hacker finds a flaw and starts draining money. We're talking 3.6 million Ether, which back then was worth a cool $60 million. For everyone who invested, it was an absolute catastrophe. This wasn't just a technical problem. It was a huge philosophical crisis for the entire Ethereum community. What do? Do you break your number one rule, that the blockchain is unchangeable, and reverse the hack? Or do you stand by your principles, let the theft happen, and say code is law? The community was completely split. But in the end, the majority voted to step in. They triggered a hard fork that basically turned back time and returned the stolen funds. That new chain? That's the Ethereum we all use today, ETH. But a passionate group of purists said no way. They believed the original chain should never be altered. So they kept it running. And that's how we got Ethereum Classic, or ETC. Now, reversing a massive hack is obviously super dramatic, but it's not the only reason for a hard fork. They happen all the time for other reasons too. Sometimes it's to add major new functionality or to fix a really critical security hole. And sometimes, like when Bitcoin split and created Bitcoin Cash, it's because the community just can't agree on the fundamental direction of the project. So what happens after a hard fork really comes down to one thing: consensus. If pretty much everyone agrees that the upgrade is the right move, then everyone switches over and the old chain just withers away. But if the community is genuinely divided, like we saw with Ethereum and Bitcoin Cash, you end up with two completely separate, coexisting blockchains. Two different coins, two communities, two futures.
All right, so if a hard fork is like major open-heart surgery for a blockchain, then a soft fork is way more like a gentle, non-invasive treatment.
A soft fork is a type of upgrade that, and this is the important part, is backward compatible. The phone update analogy works great here. When you get a new iOS update, your old apps still work, right? It's the same idea. A soft fork adds new rules, but it doesn't break the old ones. And this is the game changer. With a soft fork, you don't need every single person to upgrade. All you need is a majority of the miners, the people with the computing power, to adopt the new rules. If they do, the upgrade goes through. And crucially, the blockchain doesn't split. It stays as one single continuous chain. Actually, some of Bitcoin's most significant upgrades ever were done through soft forks. Take pay-to-script hash, or P2SH. That's what allowed for more complex stuff like multi-signature wallets, where you need more than one person to approve a payment. And, of course, there was the huge one, SegWit. SegWit was such a clever fix for Bitcoin scaling issues. Basically, it changed the way transaction data gets stored. It separated out the digital signature part, which made each transaction a little bit smaller. And if transactions are smaller, you can fit more of them into each block. Boom, more capacity for the whole network, all without having to go through a messy, controversial hard fork. Okay, we've talked about hard forks and soft forks. Let's put them head-to-head and really nail down the differences. Let's run through this table because it sums it all up perfectly. First, compatibility. Hard forks, not backward compatible. Soft forks, they are. That leads right to the next point, the result. A hard fork creates a permanent split, 2 chains. A soft fork keeps it as one continuous chain. Next up, new coins. Because a hard fork splits the chain, you often get a new coin, like we saw with Ethereum Classic. Soft forks, nope, no new coin. And finally, adoption. This is a big one. Hard forks require everyone to upgrade. It's all or nothing. Soft forks just need a majority to get on board. See the difference? One's a revolution, the other's an evolution. And just to add a little more flavor, it's not always just a simple hard versus soft thing. Forks can be intentional, a planned upgrade. But they can also be totally accidental, like if 2 miners happen to find a new block at the exact same millisecond. That creates a tiny, temporary fork that the network usually sorts out on its own in a few minutes. And of course, there's the difference between a planned upgrade everyone's happy about and a contentious one that comes from a huge fight in the community. So let's pull back and look at the big picture. What does all this mean? Here's the main takeaway. Forks aren't a bug in the system. They are the system. They're the feature that allows these supposedly unchangeable ledgers to actually grow, adapt, and get better. They are the evolution mechanism for blockchains. Whether it's a quiet little soft fork or a massive dramatic hard fork, they are absolutely essential for the survival and health of these networks. And what this really shows us is something profound. Behind all the fancy code and complex math, these systems are run by people, by communities making choices. Forks are just the most visible moments where those human decisions shape the future of technology. It really makes you think, what's the next big choice that a community is going to have to make? Hey, if you enjoyed breaking down complex topics like this one, you'll find a lot more over on our YouTube channel, CodeAccessHub. So make sure you head over there, hit that like button, subscribe, and ring the notification bell so you don't miss our next explainer. Thanks so much for watching.